In today's video, I'm going to look at a very interesting improper integrals. This type of integrals are basically complex analysis parts. Okay, we are going to use the residus theorem in order to evaluate this integral. Okay, so this is a little different than other integrals which we saw before. Okay, I'm going to do this one over unit circle. Okay, so in this case we are going to choose r equal to 1 as a radius, okay, of this circle, as gamma theta to the I theta, z equal to e to the I theta. Okay, so in this case theta is between 0 to pi. That's why we have chosen this, the whole unit circle, okay, from 0 to pi. So what I'm going to do now, I'm going to transfer the theta in terms of z, okay, from 0 to pi d theta over a plus cosine theta. Okay, as you see here, this is even function, okay, because cosine is an even function, so the whole thing is so the 1 over a plus cosine theta is an even function. So I can write it on this way as well. So this one is 1 over 2 from 0 to pi d theta over a plus cosine theta. Okay, I'm going to replace cosine theta with Euler formula, so I will have cosine e to the I theta plus e to the minus I theta over 2. Okay, so I will have a, as we mentioned before, z equal to this one because r equal to 1 as a radius of this circle. Okay, so this one a to the z plus 1 over z. So this one is giving us 2a plus z squared plus 1. Okay, for the d theta, for the we have z equal to a theta. I'm going to differentiate this one, so I will have d theta equal to dz over iz. So I'm going to plug this information into this integral, so I will have I, so 1 over 2 over gamma integral. We will have this dz, so I will have 1 over I z is multiplied by this one. I'm going to take the reciprocal of this one, 2z over z squared plus 2az plus 1. Okay, dz. I took the reciprocal of this one, it gave me this one. I'm going to cancel out z and 2, this 2 with this 2, so we'll have this integral over gamma 1 over I dz over z squared plus 2az plus 1. Okay, this is I integral. So I have changed my integral into z now, so I'm dealing with z variable. I'm going to solve this equation to find out the pools of this one. Okay, so z squared plus 2az plus 1 equal to 0. I'm going to calculate discriminant of this one, so we'll have delta equal 4a squared minus 4ac. So I will have 4c, which is 4. I take 4 outside of this one, so I will have e squared minus 1. The pools, let's call these pools lambda plus equal to minus b, which is minus 2a, plus delta of this one, which is 2, is multiplied by square of this one, a squared minus 1 over 2. So I'm going to simplify this one. I'm going to calculate the second pool, which is lambda minus. As you see here, I'm going to figure out which pool inside of the unit circle. I found 2 pools. Be careful with these pools because I'm going to take only one pool, because only one pool is inside of this unit circle, because we have condition here. So a must be strictly superior than 1. Okay, so as we know, r is equal to 1, right? As r equal to 1 as a radius of a circle. If you take a look at this term, which has minus, this is out of this unit circle, because the r must be is inferior or equal to 1. Okay, that's mean r is between -1 and 1. Okay, so this term is out of this range. Okay, this pool lambda minus is out of this range, out of this radius. So the only pool is inside of this unit circle. It is the first one, minus a plus square root of a2 minus 1, which is located in this range. Okay, so I'm taking only one pool. I'm going to clean up the board and bring this one at the top and continue with our problem. What I'm going to do now, I'm going to calculate the residues of this function for the pool lambda plus equal the limit. I'm going to replace lambda plus f of z, which is 1 over. So what I did here, I'm calculating the residue of f for the pool lambda plus, because the only pool which is inside of this unit circle. So the other pool, which is lambda minus, is outside of this one, so it's not included here. So the only pool that we have, which is inside of this unit circle, which is lambda plus. Okay, so the nice thing here, this one will be cancelled out. Z minus lambda plus will be cancelled out. Okay, so what's left, this one I'm going to replace z with the lambda plus as a pool. So we'll have the limit 1 over I z minus. So this one I'm going to replace 1 over I with this pool, because as z is going towards, as z is approaching to lambda plus, which is minus a plus square root of a square minus 1. So this a, you will be cancelled out with this minus a. So we'll have 1 over I 2 times square root of a square minus 1. Okay, residue of f for the pool lambda plus. Okay, equal to this one. So our integral to pi I is multiplied by this one. I is 1 over I. So this integral of dz over z square plus 2az equal to pi I. I'm going to cancel out I. Okay, this one equal to 2 pi over square root of a square minus 1. Okay, so we are not done yet, because we are evaluating I integral, not this one, d theta over a plus cosine theta equal 1 over 2 this integral for gamma integral dz over z square plus 2az plus 1 equal to this one. So 1 over 2 is multiplied by 2 pi, which is pi over square root of a square, pi over square root of a square minus 1. Okay, I integral equal to pi over a square minus 1. So now our integral is evaluated successfully. So this value of this integral is valid all the time as long as you have a is strictly superior than 1. Okay, as a real number. So now I have done with this problem. We will see more examples in next coming videos. Just consider subscribe. Thank you for watching. I will see you in next video. Bye.